Hi and welcome to the second Kirby Maths video about simultaneous equations. In the first video I looked at two examples where the y coefficient was the same, so we didn't have to do anything other than decide whether we were going to add the equations together or subtract the equations. Here we have to do a little bit of manipulation in order to make the y coefficients match up. So looking at this first example here then, we have got 4y on the top and just 1y on the bottom. So if I times everything in that bottom equation by 4, then they will match up the y values. So I'm going to call this equation 1 and equation 2. So equation 1 stays the same, and I'm going to write that on the top still. So 2x plus 4y equals 26. And then I'm going to times everything on the bottom equation by 4, and then I'll be able to match up the coefficients of y's. So 3 4s are 12, so 12x minus 4y, and then that equals 4 4s are 16. Now the coefficients of y matches up, but we're going to do our same signs subtract test to see if we're going to take them away, and we're not, because they don't match up, they're not the same signs. So we are going to add these two equations together, and you need to indicate clearly that that's what you're going to do. So 2x plus 12x is 14x. 4y add minus 4y, they disappear, that's your elimination part of the method. And then 26 plus 16 is 42. Divide both sides by 14 to solve for x, and x is equal to 3. Halfway there. We now need to substitute x equals 3 back into one of the two original equations. Do not substitute it into an equation you have messed around with, because if you have made a mistake and you substitute it back in, you will compound that error and it might not work out to be a very nice number. However, if you substitute it back into the original equation, it's less likely to have an error in it. Now, because of the negative sign, or the takeaway here, I'm going to substitute it into the top one. So sub x equals 3 into 2x plus 4y equals 26. 2 times 3 is 6, so 6 plus 4y equals 26. Solving for y now, we subtract 6 from both sides, so 4y is equal to 20. Divide by 4, y is equal to 5. So those are our two values for the simultaneous equation. Remember, if we plotted them graphically, that would be the coordinates of the crossing point. Let's have a look at this second example. This time, on the first one, we only had to change one of the equations to match up the y values. Here, in order to match up the coefficients of y, I'm going to times the top equation by 3 and the bottom equation by 2. And I've chosen those two numbers because if I times 2y by 3, it will give me 6y. And if I times 3y by 2, it will give me 6y. And then I know that I can eliminate them if the coefficients are the same. So let's do that then. So 3 times 3x is 9x, 3 times 2 is 6, plus 6y, and then 16 times 3 is 48. On to the second equation. 2x times 2 is 4x, 3y times 2 is 6y, and it's minus 6y, and then 2 times 2 is 4. We do our little test. Are the signs the same? If they are, we can subtract. The signs are not the same, so we are going to add those two equations together, and we are going to clearly indicate that we are going to add those equations together. 9 plus 4 is 13x. 6y add minus 6y, they disappear, that's the elimination part done. And 48 add 4 is 52. Divide by 13 to solve for x. X is equal to 4. And then, just as I did with this one, you need to substitute that value of x equals 4 back into one of the original equations from the question. Again, I don't like the takeaway sign here because I'm solving for y, so I'm going to use one where everything is positive and we're adding. So sub x equals 4 into 3x plus 2y equals 16. X is 4. 3 times 4 is 12 plus 2y equals 16. Solving for y, take 12 away from both sides. 2y is equal to 4. Divide by 2, y is equal to 2. So in this case, our values of x were 4 and our values of y were 2. Okay, so that's how we solve simultaneous equations where the coefficients of y, the number in front of the y, are not the same. Thanks for watching.